Welcome to our TechSphere podcast. We're going to be talking about self-driving cars.
Thanks for tuning in. Please like, subscribe, and share this deep dive with your friends. Please don't forget to subscribe.
All right, so everybody buckle up, because we're taking a deep dive into the world of self-driving cars. And I know it's something that you are super eager to explore. We're using excerpts from the Wikipedia article on self-driving cars today.
Yeah, it's interesting. Self-driving cars seem to always be in the news, but the reality is that we're still really in the early stages of this, whole technological revolution.
Yeah.
Late 2024. As of right now, no car on the market can really truly claim to be fully autonomous. That level 5 we often hear about.
Right. And it's like all this terminology that's being thrown around, autonomous, driverless, robotaxi.
Yeah.
It gets confusing fast.
It does.
Even the term full self-driving, which some companies use, doesn't necessarily mean that the car can really handle every single driving situation.
Yeah, it really highlights that we need clearer definitions.
Yeah.
Doesn't it? I mean, it's almost funny. In the UK, a fully self-driving car can be defined simply by its registration, not its actual capabilities.
Oh, wow.
Imagine, an insurance claim process. But officer, it's fully self-driving. It says so right here on the paperwork.
That's a really good point. So that lack of clear definitions could create some real-world headaches, from insurance confusion to potentially misleading marketing.
Yeah.
So how can we as consumers sort of navigate that and ensure that we're not being misled by the hype surrounding self-driving technology?
Well, I think for starters, understanding the history of it can give some context.
Yeah.
It's actually a lot older than most people think.
Oh, really? I kind of assumed that self-driving was pretty new.
No, not at all. Experiments with systems that aid driving, what we now call ADAS, Advanced Driver Assistance Systems, those have been around since the 1920s. Even, basic cruise control, which most people just take for granted, was invented way back in 1948.
Wow, so this quote-unquote future tech actually has roots like almost a century old.
Almost a century, yeah.
That's incredible. But when did we start seeing cars that could actually drive themselves? I mean, even if it's, just a little bit.
Well, researchers in Japan in 1977 developed the first semi-autonomous car. But here's the catch. It needed special streets with markings just for it to navigate.
Oh, okay.
It's kind of like, if you have one of those toy cars and you need to lay down a specific track for it to follow. It's kind of like that.
Okay. Baby steps.
Yeah.
But I'm sure there were some major breakthroughs that kind of got us closer to where we are today.
Yeah, for sure. In 1995, a vehicle called NavLab 5, they completed the first autonomous coast-to-coast journey across the U.S. And get this, it drove itself for 98.2% of the trip.
That's really impressive.
Pretty impressive, right?
Yeah, it is. So let's talk about this level system.
Yeah.
I think this is what everybody keeps, mentioning. It seems like there's a whole ranking system for how self-driving a car actually is.
Right, there is. The SAE International, a group of automotive engineers, they created this 6-level classification system to define driving automation. What's important here is that this focuses on the driver's role, not just the car's technology.
So at level 0, it's, all me, just like every other car I've driven.
Exactly.
But as we climb these levels of autonomy, things start to get a little bit more interesting. Let's see how the car actually starts to share the driving workload.
Sure. So level 1, you might have some driver assistance features, lane keeping assist, for example, but you're still the one fully in control.
Right.
Level 2, it's like having a co-pilot helping with things like steering, speed control. A lot of the cars on the road today, the ones that have, adaptive cruise control, lane centering, that kind of thing, they fall into this category. Okay. But it's really important to remember, even at level 2, you need to stay fully engaged and ready to take over at any time.
Gotcha.
The car is assisting, it's not replacing you.
Right. Okay, so level 3, this is where we start to get closer to that, quote, eyes off the road, close quote, dream.
Yeah, level 3 is where things get really interesting. It's called conditional automation.
Okay.
It means the car can handle most driving tasks under certain conditions.
Okay.
However, the driver must be ready to take back control if the system asks for it.
So, theoretically, I could watch a movie, but I have to be ready to grab the wheel if the car gets confused.
Theoretically, yes. But as of today, there are very few level 3 cars that are commercially available, and their capabilities are limited to very specific situations.
Okay.
Like highway driving in good weather,
Yeah.
You can think of it as a very, very advanced cruise control system, but with some extra smarts built in.
Okay, all right. So what about level 4? Is that when the car can really, truly handle itself in most situations without my input?
So level 4 is called high automation, and this is definitely getting much closer to that vision. At this level, the car can operate without any human input,
No.
but it's within what's called a specific operational design domain.
What does that mean?
So think of it as a defined geographic area or a set of conditions that the car is really familiar with.
Okay, so like a robotaxi service that operates only within a certain city.
Exactly.
Okay.
And even at level 4, there may be limitations. For instance, imagine really, really bad weather conditions. The car may require a human driver to take over.
Okay.
The key difference at level 4 is that the car can safely stop and wait for help if it encounters something it can't handle.
Gotcha.
It doesn't need you to immediately take over.
Okay, that's pretty amazing. So level 5 is like that ultimate goal of a true driverless car, right? The one that can like handle anything anywhere.
That's right. Level 5 is full automation.
Okay.
A car that can navigate any road in any condition, just like a human driver.
Right.
But this is still very much a work in progress. It's the ultimate goal, but we're not quite there yet.
All right. So while we're waiting for level 5 to arrive, how about we kind of pop the hood and take a look at the tech that actually makes all of this possible?
Let's do it. So the first thing to understand is how these cars see the world around them. And I'm not talking about our 5 senses here.
Right.
These cars use a whole bunch of sensors to perceive their surroundings.
Oh, so this is where it gets really interesting. Tell me more about these superhuman senses.
It might surprise you to learn that self-driving cars use cameras, LiDAR, which is like radar but with lasers. They use ultrasound for close-range detection and even GPS to help with location. It's all about giving the car as much information as possible about its surroundings.
Wow, so it's like giving the car like superhuman senses to navigate. What happens once the car gathers all of this sensory data?
Well, that's where the brains of the operation come in. Artificial intelligence and deep neural networks. So these systems analyze the data from all those sensors to not only identify objects like other cars, pedestrians, and traffic lights, but also to try and predict their behavior.
So it's not just about seeing, it's actually about understanding
Yes,
what's happening around the car and kind of anticipating what might happen next.
Exactly, you got it. The car needs to predict if a pedestrian's going to cross the street or if the car in front of it is about to brake suddenly. And that's where AI is really, really good. It's constantly learning from new situations and adapting its responses.
And speaking of different approaches, we've heard a lot about, Tesla's vision-only system versus others that use a wider range of sensors like LiDAR. Could you explain the difference between those approaches?
Sure. So this is a big debate in the field right now. Tesla believes that cameras alone, just cameras, can provide enough information for safe driving. Other companies like Waymo, they say that adding things like LiDAR gives the car a much more robust, much more detailed view of the world, especially in, tough conditions like bad weather or low light.
It's almost like some people prefer to read a book while others need to listen to an audiobook.
Yeah, I like that.
Different ways of processing that information.
That's a great analogy. Yeah. It's all about finding the most effective way to gather and interpret the information for safe driving. And remember, it's not just about sensing the world. It's about planning a path. Figuring out the best route to take, navigating those turns, avoiding obstacles. And this often relies on maps. And these maps can range from basic road networks to really, really detailed 3D models of the whole environment.
Wow, that's incredible. So much is happening before the car even moves an inch. But we've got to remember that there's still some bumps in the road here.
Yeah.
Some challenges and concerns that need to be addressed before these cars become, mainstream.
Yeah, you're absolutely right. It's not all smooth sailing just yet.
Right.
And one of the biggest concerns, of course, is safety. I mean, how can we be sure that these cars are going to be able to handle all the crazy things that can happen in the real world, especially those, tricky edge cases that can stump even the most advanced AI?
What's an edge case?
Imagine a construction zone with unexpected detours.
Okay.
Or a sudden, downpour that obscures all the road markings, or even, a bunch of birds flying across the road. Those are the kind of things that, those unpredictable events that self-driving systems need to be able to navigate safely. And those are really, really difficult to program for.
That makes sense. It's those unexpected situations that can really throw things off.
Oh, yeah.
And then, of course, there's the ethical dilemmas, like the classic, what is it, the trolley problem.
Right.
So if the car has to make a split-second decision to avoid an accident, how does it actually choose who to protect?
Yeah, these are really tough questions.
Yeah.
There's no easy answers. And these ethical considerations are all kind of tied up with legal questions, too, about liability. If a self-driving car is involved in an accident, who's actually responsible? The owner of the car, the manufacturer,
Right.
the software developer.
That's a lot to unpack.
And then there's security and privacy concerns. I mean, think about it. These cars are collecting so much data about our driving habits, about where we go, even, what's happening inside the car.
Yeah.
Protecting that information from hackers, making sure it's not misused is really, really important.
Right.
And then we also have to think about jobs. What happens when, self-driving trucks become common? What happens to the millions of truck drivers who make a living on the road? These are big societal questions we need to address as this technology keeps changing.
Yeah. I mean, it's clear that self-driving cars are more than just this, cool tech gadget.
Oh, yeah.
They have the potential to really reshape our world in some pretty big ways, positive and negative.
Absolutely.
Before we dive into testing and incidents that have really kind of shaped this field, maybe we can pause here for a second.
Sounds good.
We'll be right back to continue our deep dive into the world of self-driving cars.
Stay tuned. So before we send these self-driving cars out to the world, they go through tons of testing. It's like driver's ed, but for robots.
Right.
And it's a mix of things like simulations, controlled environments like test tracks, and then eventually real-world testing on public roads.
I can only imagine what those simulations must be like. Virtually recreating all these crazy driving scenarios to see how the AI reacts.
Yeah, it's pretty wild. They can throw anything at the car in a simulation. Snowstorms, traffic jams, jaywalking pedestrians, you name it. And all without actually putting anybody at risk. But eventually, they do have to go out into the real world, which brings us to something called disengagements.
Disengagements. That sounds a little ominous. What does that mean?
Well, it's not necessarily a bad thing. It just means that the self-driving system encountered something it couldn't handle, and it had to hand control back to the human driver. It's like a built-in safety measure. And it's actually used as a way to assess how reliable the system is.
So the fewer disengagements, the better, I assume.
Generally, yeah. But it's not a perfect way to measure things. Sometimes a disengagement might just be because the programming is too cautious, not that the system actually failed. And as these cars get more advanced, companies are defining disengagement in different ways, which makes it really tough to compare things directly.
It's like trying to grade a test where the questions keep changing on you.
Exactly. And speaking of tests, in the U.S., companies that are testing self-driving cars are required to report any incidents that happen to the National Highway Traffic Safety Administration, or NHTSA for short. This helps to track any problems that come up and to improve safety standards for everyone.
I bet those reports are some interesting reading. Have any, notable trends or patterns come out of that data?
Well, one thing that people have pointed out is that there seems to be a high percentage of incidents that involve Tesla vehicles. But it's super important to remember that this doesn't automatically mean Tesla's technology is less safe. Tesla has a ton of cars out on the roads with their autopilot system turned on. So just statistically speaking, it's more likely to be involved in incidents. It's kind of like saying the airline with the most flights also has the most delays, right? Not necessarily a sign that they're doing a bad job, but just that they're doing a lot more.
Right. Correlation doesn't equal causation. That's important to remember.
Absolutely.
But have there been any specific incidents that have had a really big impact on how self-driving cars are developed?
Sadly, yeah, there have been a few, and some of them have had really tragic consequences. One that really stands out is the one that happened back in 2018. It involved an Uber test vehicle.
Right.
It struck and killed a pedestrian in Arizona.
I remember that. It was all over the news.
Yeah, it was a defining moment for sure. The first known fatality involving a self-driving car.
Wow.
And it really forced the whole industry to take a long, hard look at safety protocols and how challenging it is to test in these complex, real-world environments.
Right.
The investigation showed there were a few things that contributed to the accident, including some problems with how the car's perception system was working and the fact that the safety driver, who was supposed to be paying attention, was distracted. It led to some big changes in testing procedures and really emphasized how crucial it is to have strong safety measures in place, even in situations that seem controlled.
It's like a really stark reminder that even with all this incredible technology, we still have this human element involved, and that's where things can get a little unpredictable.
Yeah, for sure. And it's not just Uber either. There have been incidents with other companies too, Tesla, Waymo, and each one, while, obviously unfortunate, provides valuable lessons and highlights areas that need improvement. They're like crucial learning experiences for the entire industry. They help to identify weaknesses and push for even tougher safety standards.
So it's this constant process of like testing, learning, and then refining the technology, always trying to make it safer and more reliable. But what about the public? How are people reacting to all of this? Are they ready to jump into self-driving cars, or are they still hesitant?
Public opinion surveys show kind of a mix of reactions.
Okay.
Some people are really excited about what self-driving could mean, like increased safety, less traffic, and the freedom to chill or get some work done during their commute.
Right, I get that. I could see the appeal of that for sure. Getting all that time back you normally spend driving. But I imagine that some people are still on edge about letting a car drive itself, especially after hearing about these incidents we were just talking about.
Yeah, totally understandable. There are definitely valid concerns about how reliable the technology is. What if it gets hacked or malfunctions? And of course, some people are anxious about what it could mean for jobs, especially if you're a professional driver.
It makes me think about how people reacted to automatic elevators back when they first came out.
Yeah, that's an interesting parallel. Think about it. People were kind of freaked out about elevators without a human operator at first. They worried about safety, like what if it gets stuck? They weren't comfortable not having a person in control. But over time, as the technology proved itself and showed that it was reliable and convenient, automatic elevators became totally normal.
It's a good example of how our perception of technology can change as we get more used to it and see how useful it can be.
Totally. So the question is, will we see the same thing happen with self-driving cars? Will they eventually become as common as elevators and completely change how we get around?
Something to think about. So I'm curious to hear more about the different levels of automation that are already out there for people to use. It seems like the tech has come a long way, and I'm wondering how close we are to seeing these self-driving features in like everyday cars.
Yeah, let's get into that. We can start with level 2, which is where most of the self-driving tech is at right now.
Right.
It's what people call partial automation, and it's becoming more and more common in new car models. Features like lane centering, adaptive cruise control, automatic emergency braking, they all fall under level 2.
I've seen a lot more cars on the road with those features.
Yeah.
It's kind of like having a co-pilot, but one that never gets tired or loses focus.
Yeah, exactly. And these systems can make driving a lot less stressful and potentially even safer, especially when you're on long highway drives. They can help you stay in your lane, keep a safe distance from other vehicles, and even slam on the brakes if you don't react fast enough.
It's like a safety net while you're driving.
Yeah.
But you still got to have your hands on the wheel and be ready to take over whenever,
Yeah.
right? It's not truly hands-free yet.
Right, exactly. Level 2 systems are designed to work with the driver, not to replace them entirely.
Gotcha.
And it's super important to remember that they do have limitations and can't handle every situation. It's a team effort, The car's helping you drive, but you're still the one in charge.
Makes sense. Okay, so what about level 3 then? That's the one that's supposed to let you take your eyes off the road, right?
Right. Level 3 is called conditional automation, and it does allow for the driver to take their hands off the wheel and look away from the road, but only in very specific situations.
Oh.
The car can handle most of the driving tasks, but the driver has to be ready to jump back in if the system can't figure something out.
So you're probably thinking, level 3, that's where I can finally watch a movie while driving. But is it really all it's cracked up to be?
Well, as of late 2024, there aren't many level 3 cars actually available to buy, and what they can do is still pretty limited.
Okay, one example is the Honda Legend. It has a level 3 system they call Traffic Jam Pilot. And like the name suggests, it can handle driving in slow-moving traffic on highways. So, yeah, you could theoretically watch a movie, but...
Wait, really? I could actually watch a movie while driving? That's wild. But also kind of scary.
It is pretty cool. But you got to remember, this only works in very specific conditions. Slow traffic, nice weather, clearly marked lanes. If the car runs into something it can't handle, the driver needs to be ready to take over immediately.
It's kind of like having a chauffeur, but one that might suddenly get confused and need you to step in.
Yeah, good way to put it.
So it seems like level 3 is more about helping the driver than totally replacing them.
Exactly. It's a step towards being fully automated, but just a step.
Okay, I get it. So what about level 4 then? Is that where we finally reach true self-driving? No human needed at all? Level 4, which is what we call high automation, is the closest we've gotten to that true driverless experience. At this level, the car can drive itself without any human input at all. But there's a catch. It can only do this within what's called a specific operational design domain. So think of it like a specific area that's been carefully mapped out or a set of very specific conditions that the car's been programmed to handle.
So like those robotaxi services that operate only within a certain city or along certain routes.
Exactly. And companies like Waymo are actually doing this already.
Wow.
They're running robotaxi services in places like Phoenix, Arizona, and San Francisco, California, where their cars can drive around in these specific areas without a human behind the wheel at all.
So those robotaxis are really level 4. That means they're out there making decisions in real time without a human calling the shots. Does that thought make you excited or a little nervous?
Both, probably. It's definitely exciting to see the technology advancing like this. But it's also important to remember that level 4 systems still have their limits. They can still run into problems if something unexpected happens, like really unusual weather conditions, or if they encounter obstacles they weren't prepared for. But the key difference with level 4 is that if the car can't handle something, it can safely stop and wait for help. It doesn't need a human to immediately jump in and take control.
Wow, that's a pretty big step toward a future where cars can truly drive themselves. It seems like that future is coming faster than we think.
It really is. So I'm guessing level 5 is the holy grail then, where the car basically becomes your personal chauffeur, handles any road, any condition, just like a human driver would, but without all the human limitations.
You got it. Level 5, what we call full automation, is the ultimate goal. A car that can truly drive itself anywhere, anytime, no matter what. But like we've talked about, we're not quite there yet.
We're getting closer every day, though. I mean, think about it. We already have level 4 robotaxis out there on the roads.
It's a really exciting time to be witnessing this whole technological revolution unfold.
It definitely is. And the next few years are going to be super important in determining what the future of self-driving cars looks like. We're going to see even more advancements in AI, sensor technology, mapping, and even more testing to make sure the safety protocols are as strong as they can be.
And hopefully, as the technology keeps getting better and proves itself, people will start to feel more comfortable with it, and we'll see even more of these self-driving features in cars everywhere.
That's the hope. But it's important to remember that self-driving cars are more than just a really cool piece of tech. They have the power to totally change our cities, our economy, and even how we think about transportation itself.
It's a conversation that goes way beyond just the nuts and bolts of the technology.
Absolutely.
All right, well, before we dive into those bigger implications, let's take a quick break to gather our thoughts.
Sounds good.
We'll be back in a bit to wrap up our deep dive into the world of self-driving cars. Okay, so we're back, and I think it's time to kind of shift gears a little bit. Look at some of those bigger implications of self-driving cars that you were talking about. I mean, it's really kind of mind-blowing to think about how much could change, if these vehicles really do become like the norm.
It really is. Imagine, way fewer traffic accidents, less congestion on the roads, and, more people being able to get around, even if they can't drive themselves.
Yeah, it sounds like a dream for like commuters everywhere.
Yeah.
But let's be real, a change that big would probably come with some challenges too, right?
Oh, absolutely. I mean, every big technological shift has its growing pains. We've already talked a bit about jobs and how some people's jobs could be affected.
Right. And it's not just those truck drivers, right?
Mm-hmm.
It could have a ripple effect on, taxi drivers, delivery drivers, even bus drivers.
Mm-hmm.
How do we make sure this transition is fair for everyone?
Yeah, that's a really important thing to think about. We need to be proactive, thinking about retraining programs maybe, or creating new opportunities as things change. It's not just about, trying to prevent the negative impacts. It's also about making sure we use this technology in a way that benefits everyone.
For sure. Thinking beyond jobs for a second, what about how our cities are designed, our infrastructure? Like, if fewer people own cars, does that mean we won't need all these giant parking lots and parking garages anymore?
Yeah.
Will cities be totally redesigned to work with these shared autonomous vehicles?
I mean, the potential for change is huge. Think about cities with more cars, more areas for people to walk around, where getting from point A to point B is easy and efficient. Self-driving cars could even change how public transportation works, offering rides on demand, personalized routes that adapt to what's happening in real time.
It's amazing to picture how our cities could be totally different. It's like we get to start over with urban planning.
Exactly. But of course, there are those ethical and legal things we talked about earlier that we still need to sort out. Yeah.
As self-driving cars become more common, who's responsible if something goes wrong? That's going to become a really big question.
It's true. We talked about that, trolley problem, but there are so many ethical questions that come up. How do we teach these cars to make good decisions in difficult situations? And how do we make sure all the data they're collecting is kept private and secure?
Those are all super important questions, and they're not going to go away. In fact, as we move closer to this future with self-driving cars, these questions are going to become even more urgent.
It's a lot to take in, but they're conversations we need to be having right now, especially as the technology keeps getting better. It feels like we're on the edge of something really new, not just in transportation, but in how our whole society works.
I think you're right. Self-driving cars are more than just a cool new gadget. They could change how we live, how we work, how we interact with the world around us in really big ways.
It's exciting and a little bit scary all at the same time, right? To think about all that change that could be coming. Definitely. It's exciting and a little bit intimidating to be figuring this all out as we go. But like with any new technology that has the potential to change things so much, we have the opportunity to guide how it develops and to make sure it's used for good.
Well said. As we wrap up this deep dive, I want to leave our listeners with one final thought. If self-driving cars really do become part of everyday life, how do you think it'll change your life, your community, how you think about getting around? It's something to think about as we head into this future. Exciting and maybe a little uncertain. Thanks for joining us on this deep dive into the world of self-driving cars. Don't forget to like, subscribe, and tell your friends about the TechSphere podcast.
And keep those wheels turning.
Well,